Welcome all to my sixth lecture out of 13 lectures. So till now we were talking about mostly the header files, but there are some important files which we'll always include as a part of project, specifically when you work for C2000 microcontrollers. So we'll see in this lecture the use or the purpose of each and every files which we are normally including in the project. So the first header file which we really want to understand is this F280015. So this is the device which I'm taking as a reference. So this particular device.header file. So if you try to take up any of the examples provided by in the C2000, where you can see this this particular header file is getting included. So what is there in this header file? It consists of some assembly functions, some compiler specific instructions, then user-defined data types, and then it also includes all the different other header files is also included in this header file. So now let's try to open this header file and try to understand. So the location is given. So the location is C2000 device support, and like whichever the device you are going inside, you can see headers include. So let's try to copy the whole header files and try to put it in our working folder. So let's do that. So I'll try to create a folder named header files. Then I'll try to include all the header files. So now you can see the header files comes to our working folder. So let's try to understand what is there in device.header file. So there are some compiler specific keywords. So this _C register, it says that it's something like a CPU register, not a normal peripheral register. And then you can see, like, we normally will use some ENT, DINT to disable some interrupt, enable some interrupt, which is replaced. The macros will be replaced by its assembler functions. So this instruction is also specific to the controller. And then you can see other different macros, which normally we'll use it for some interrupt setting. And then there are some standard header files we are getting included. And then we are including having some user-defined data types. So int can be called as int16, long can be called as int32. So we are trying to have some different names based on our convenience, or TA provided this particular data type names. And then what we are trying to use is like the whole different header files of the different peripherals is also getting included in the header file. So which means then you don't want to include individually any of the header file. Once you include the device.header file, automatically it includes the all other different peripherals header files, or basically the structure declarations in your project. So that is the purpose of including your device.header file into your project. So now let's try to include this into our project. So hash include. So we have these header files. So we'll try to include the header file folder and then the device.h. So now it should be able to detect this header this particular header file, and not only the header file, all other peripheral header files also it will get included. So now let's try to try to make our or try to build our project. So you are able to see there are some errors. One is something, this byte peripheral. So this is something specific to the compiler. I'll try to just remove this this particular word. I'm just saying that it can be called as BP16 as well. And then what you're able to see is this this PIE vector.header file, you are able to see that this particular keyword is not getting recognized by the is not getting recognized by this GCC compiler, right? So basically, this type def is void when you put inside a bracket a pointer. It's basically a function pointer. So I just replaced by this like just removed the hash interrupt. So then this is a standard function pointer type definition. So I think the compiler should be able to recognize this. Now let's try to again type make. Yeah, now you are able to see that the whole header files are getting included. So now let's jump to the next file. So the next file is this global variable defs. So the name itself, it says that you are trying to define some global variables. So the structure instances for all different peripherals are created. Even though we use or did not use certain peripherals, the memory section of peripherals are always reserved. This is something you want to really understand. So you cannot use the peripheral memory section for some other purpose. So it's always used for this particular, or it is reserved for each and every peripheral, even though in your application you are not using this particular peripheral. So now let's try to see this global variable definition dot header file. So you can see it's in the headers source. So let's try to go over there. So you can see header source. So let's try to copy this and try to paste it into our project. Okay. Now what we can see is this global variable definition.c. It's available over here. So what are we trying to do is the different structure declaration is available. So you are trying to create an instance of this particular some particular structure, right? So if you see this maybe GPIO, you can understand, because in the previous lecture I tried to explain you like the usage of GPIO. So you can see this GPIO control rec is the one main structure where it consists of various other sub elements. So you are trying to basically create an instance, or creating an instance of this particular structure, right? Then what I will recommend is try to this hash pragma. Basically, we are trying to say that this particular GPU control rec should come into one particular data section named as GPU control rec files, but GCC compiler will not be able to identify this hash pragma. So the format is something different. But what is required for us is maybe these statements are not required really for us. So what I will try to do is I will try to use this SCD, which is a powerful editor, which can be really used for removing, identifying some portion, removing all these stuffs, and you can use it directly in the VS Code. So I'll just try to paste it here. So SCDI in this file itself, I will try to identify this hash if definition to endif, and then I will replace this in this particular file itself. So this is our file called as global variable def. I'll just enter it. Then you can see, the whole hash pragma got removed. Now, what is next step is you want to, include, include this .c file also to your make file. So what we are trying to say is try to compile the whole three source files together. When you have some makefile provided by some IDEs or some OEMs, normally these things you will not be able to see. But if you really want to compile the whole thing, you want to basically give the whole source files together, so that the compiler will see the linking between the different source files. All right. So this is also next step what we have completed. Next, what you want to do is, now let's go to our main.c. Now if you try to type your the structure, you can see every structure is available. You can use the structure whatever you want. PWM also, and try to use it, and then you can you can use bitwise, or the whole the whole structure as well. Everything can be you can assign the values and you can do some debugging. You can do lot many things basically. So 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 we have saved this, and if I try to run the make, yeah, I think device.header file, which is inside, yeah. So I think here we just want to, because it is inside the header file, so just give the path header files. Yeah, yeah. So I think, yeah, it should be able to find this, and then let's try to, yeah, make, and you can see the yeah, the different objective file and other files are getting generated. So now let's try to jump to this file. This normally there are two different types. One is your driver library format, and the other is some bit field. So this particular lecture is we are trying to emphasize on a bit field. So in this .cmd file also normally we will use it. So we'll try to get an understanding. So the start and end location of peripheral registers are given in this file. Now the structure what we have made or declared is aligned with corresponding memory location. Now let's try to understand this. So if you try to go to this location, so headers CMD. So let's go to headers CMD. You can see there are two types, BIOS and non-BIOS. We are talking about in a project where we are really not using any operating system. So it's an without any RTOS or operating system we are trying to talk about. So let's try to copy this and then try to paste into our project. Now let's try to open this this particular file. So you can see there are different peripherals, and you can see the start address and the end address. So to have an understanding, what does it mean, what you can do is we can go to some data sheet uh, data sheet of the corresponding microcontroller. So let's jump into the uh, data sheet. So you can see the different peripherals. So let's try to take ADC-A. So ADC-A, it says ADC result. So if you try to say result, it starts with B00. So it says B00. So if you really want to know the length, so you can refer the technical reference manual, not the data sheet. You can see what is the length of this particular memory which is required. So you are trying to say the start address of the different peripherals or the memory locations, what is required for the different peripherals are given in the data sheet. And to know the end location, basically you want to refer to the technical reference manual, right? So you are trying to this is the first section, memory section, and then there is an important section. Second section is what we are trying to say is, now whatever the name which we have given, the hash pragma section, we are saying that this particular portion should get aligned to this portion. So by doing so, what we are trying to achieve is like the structure, whatever we are declaring will go and sit into that particular memory location. So that is what we are trying to do in this particular .cmd file. So I hope you got some understanding. Maybe let's try to get more understanding. So let's try to copy this, try to get get some understanding. So what I'm trying to say is, let's try to take the GPU itself. So what we are trying to say is, we have created the GPU data red drugs, and then we are saying that this particular section has to have a particular, under a particular section called as GPU data read recs files. Right now, when you try to see here, you can see the GPU data rec files. This is the portion. So this portion should have a memory location of GPU data read, and this memory location we have defined at the top of the table. So that the structure, the structure will get aligned to this particular memory location. So hope you got some insights on this. And then what we will see is this code start branch.asm file. So what are we trying to do with this code start branch.asm file is, After the power on reset, there is there is some reset vector. I'll try to show you in the next video, or in the next video lectures, like uh, where you can really understand a little bit more. But to just give you a starting, we will give you a code start.branch.ism. So what does it basically does is, it will have some power on reset and it will go to one location. You'll read the boot mode. So whether you want to jump to flash, jump to CAN, there are different options. And then normally if it is jump to flash, then normally we'll give some C underscore init 0. This C init underscore init 00 calls some boot.asm file. So what does this mean? So you have this boot.asm file in this particular location. So let's try to open this as well. If you try to search for boot.asm, let's try to open with some notepad. So there are different things which is going on. From the C init 0, it goes to boot.asm, and from the boot.asm, basically the main function will get executed. So you can see at the end of the file, we will call the main. So let's try to search main, execute main. Yeah. So you can see at the end of the boot.ism, we will try to point the program to the main. So where we will start writing in the main. That is the starting point of the code. From there onwards, it's application code. Then the program starts executing. So for any of the projects which normally you will see in in your example. So maybe let's try to open some example. Let's try to check these files in the project. Let's try to import a sample project. So CCS project, browse. So yeah, I'm trying to open some example of some timer example. Let's try to open this. So we should be able to see the different files in this example. So if you see this is just the main file, CPU timers.c file. So if you try to go inside this project.h header file, you can see this device.header file, which I try to show you. So this is one of the prerequisite or file which is really required. And then what we have discussed is this global variable def.c. So this is also another file which we talked about. And then we talked about this non-bias.cmd file. So where the memory location is given. So, and then if you try to go to the code start branch.ism. So here there is something called simple management. So you can see this code start. So specify program entry point for the output module. So once you finish the reset, where should it go? It should go to code start. And then you can see the code start branch.ism file. So you can see something called this code start, and then from code start we go to C init 0. So then the branch to start the boot.ism. So from the boot.ism, then basically it will call the main function. So this is how the flow of the program happens after the reset of the microcontroller. So hope this video was an insightful one and you got some good understanding. So if you would have missed some points, I request you to watch my previous videos to have some true understanding. Thank you all. See you all in my next lecture.